In the last class, I had discussed the elasticity of demand curves. Okay, sorry, I'll just start my presentation. So in the last class, I had discussed the concept of elasticity of demand curves. Since some of you were not present in the last class, I'm going to just go through the concept and then come to the point that I'm trying to make. So we have a demand function. Oh my God. Okay. So we had said that demand has two aspects. First of all, it refers to desire to acquire something, acquire a good, but this demand, this desire must be backed up by adequate purchasing power. Now, the demand function is written in this way. QD is the amount that you want to purchase. It depends upon own price, price of related goods, which is complements or substitutes. M denotes income, T is taste and preferences, and we can think of other factors like seasonality, etc. Now, in the last micro class, you had referred to something called, I think MD had discussed the bandwagon and snob effects. Can you incorporate these two effects into the demand function?
No, sir, it is an exception to the law of demand.
Suppose we write the demand function like this. So this is the same as before, and we put in an N. N is number of consumers who are purchasing the particular commodity, right? In that case, N can affect the demand in two ways, positive. So if N increases, demand for X increases, or we can think of, sorry, if N increases, then Q falls, which is negative. Okay, which is the bandwagon effect and which is the snob effect?
Sir, the positive one is the bandwagon effect, and the next one is the negative one is the snob effect.
So this is
Snob.
bandwagon and this is snob. So if you see that other people are buying that commodity, it has become fashionable. A film has opened and it's houseful in all the shows. So a craze develops. Everyone goes and tries to get a ticket, even purchasing it in the black market. On the other hand, there's some commodity you may want to behave in a contrary manner. So if all the people are purchasing, you're a snob and you said, look, I don't want to purchase this commodity. I'm special. So in that case, if others purchase, you reduce your demand. And how can we show this in terms of diagram? Let us talk about the bandwagon effect. This is price and this is quantity. And this is the demand function.
Sir, rightward shift of the demand function of the
Okay.
demand curve.
Okay. Uh, Before saying whether your answer is right or wrong, let me tell you a story. Very short story. Uh, a very young cricketer. Do you like cricket?
Yes, sir.
Okay. So a very young cricketer, he was very promising, and he had gone to the coaching center. And his coach was telling him, showing him how to pull the ball. So after he practiced for about half an hour, the coach came up to him and said, or rather asked him, okay, suppose the bowler bowls to you. Now tell me, what stroke will you play? So that player said, thought, just a minute, if someone has come in. Yeah. So the player said, look, you have been teaching me how to pull. So I'm going to pull the ball. And the coach said that suppose instead of a short ball, it was a Yorker, will you still pull it? Pull it. In this case, I mean, why I told you the story is suppose that N has fallen. In that case, will you still have a right foot shift?
No.
Okay. So when you're saying right foot shift or left foot shift, define what is N. So this will occur if, sorry, if N increases. On the other hand, if N falls, there will be a leftward shift. So we call this decrease in demand. Rightward shift, and this is increase in demand. Okay. In case of a snob effect, what will happen? It's exactly the opposite for a snob effect, right? So that means if N decreases, you will want to purchase the commodity. It will be a rightward shift, increase in demand. If N increases, you don't want to purchase the commodity, demand will decrease, there will be a leftward shift. Okay. Now, if we look at movements along the demand curve, so we are moving from a point like A, either upwards or downwards. What is the factor which is causing the change?
The change in
The
price.
change in price.
So the
It is
price of the good.
a change in price. Okay. So the law of demand says that price and demand are inversely related. Okay. So if price goes up, demand comes down and vice versa. Now the question is that fine, if price goes up, demand falls. But how much does demand falls. Okay. So to answer this question, how much, we have to introduce the concept of elasticity, elasticity of the demand curve. And this is defined as del Q by del P. So we can also write this as, and the minus here indicates that the slope is negative. So the elasticity is basically a measure of the responsiveness of the demand curve, responsiveness to price changes. We can also think of how much demand changes when income changes. That is called income elasticity. We can also think of responsiveness when price of related goods changes. That is called cross elasticity or cross price elasticity. Okay. Now I've told you that elasticity can be equal to infinity. This is infinity. At the other extreme, this is equal to 0. This is equal to 1. We call it unitary. This is perfectly elastic. This is perfectly inelastic. And in between, we have, this is called highly elastic or elastic, and this is called inelastic. Okay. Now, a priori, we may think that the unitary elasticity should comprise to a linear demand curve. Okay. But the linear demand curve poses a very interesting problem with respect to elasticity. Suppose we have, suppose this is the point at which a consumer is located. So he's purchasing Q when the price is P. And this is a straight line. In this case, we can show that elasticity is equal to, sorry, I made a mistake. Elasticity is equal to this lower segment by upper segment. Just hold on for a minute. Hello? আচ্ছা। হুম, হুম। আচ্ছা, আচ্ছা, ওটা বলতে খুব ইম্পর্টেন্ট হবে না, যাই হোক ওটা নিয়ে নেবো আমি। হ্যাঁ, হ্যাঁ। আচ্ছা, আমি যদি একটা ইমেল করে দিই। হ্যাঁ, 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 হ্যাঁ। ওটা ওগুলো তো ইম্পর্টেন্ট, ওগুলো আমি ইমেলে পেয়ে গেছি। আচ্ছা, আমি তাহলে একটা মেল করে দিচ্ছি, আপনাকে একটা সিসি করে দেবো কি? আচ্ছা, 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 বুঝতে পারছি। আচ্ছা, আচ্ছা, ওটা কবে এসেছে আহ, বোঝা যাচ্ছে না। হ্যাঁ, 7th। ও তাহলে 4th নভেম্বর, তাহলে ওটাই হবে, সার্ভিস বুকটাই হবে। আচ্ছা, 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 তাহলে ওটাই হবে। ঠিক আছে, আমি তাহলে একটা মেল করে দিচ্ছি। Okay. Sorry for the interruption. Actually, there's a call from the university. Okay. Uh, Let me see. Okay. So elasticity is equal to B by C divided by AB. Okay. So we can call this the lower segment and this is the upper segment. So you can say it's the ratio of the lower and upper segments. Now the proof is as follows. See, what is the definition of elasticity?
The degree of responsiveness
No, the
to the
mathematical.
change in quantity. Yeah.
Quantity
Yeah,
demanded over change in price.
yeah. Okay. Now, what is price over here? It is OP. What is and what is demand? Demand is
OQ.
OQ. What is the change in demand? It is PB, and the change in price is oh, AP. So basically, sorry, this by this, we are writing over here. Slope is del y by del x, right? This is del y, this is del x, and this is the inverse of slope, right? So this is PB by AP. Okay. Now PB is this, OQ is this. So these two cancel out, and we are left with OP by AP. Okay. Now, if you look at this two triangles, this triangle, and if you look at this triangle, these two triangles are equivalent triangles. You're simply scaling up the smaller triangles. Okay. Therefore, the ratio of these sides are going to remain same. What you're simply doing in this case is you're expanding this by a certain fraction. Therefore, you're expanding each side by the same fraction. Okay. So if you're changing this by increasing this by lambda, this is also being increased by lambda. Therefore, OP by AP is equal to BC by AB. Okay.
Sir, I didn't get you. These two triangles are equivalent triangles or like similar triangles?
Yeah, these are similar triangles. Sorry.
Oh, okay.
So using the definition of similar triangles, we can see that OP is this and this. So this ratio will equal to this ratio. Now, what does it imply for elasticity? Let us take the midpoint. And we call this B0. So elasticity is equal to C B0 by A B0. And because it's the midpoint, it is equal to 1. So we have unitary elasticity. Now, along the straight line demand function, it's a linear demand function. What are the properties of the demand function of a linear function? The slope is constant. Okay. So this may lead us to argue that because slope is constant, elasticity will also be constant and equal to 0, which is wrong. If you look at a point like B1, so B1C and A B1. So this is greater, therefore it is elasticity will be greater than 1. On the other hand, if you take a point like B2, you have this, right? So that means elasticity varies at all points. At different points on the straight line demand curve, elasticity will be different. At this point, elasticity will be equal to 1. And as we move up, the value of elasticity is going to increase. If you move like this, the value of elasticity is going to decrease from 1 and move towards 0. Okay. So as we move like this, from 1, it becomes 1.1, 1.2, 3, 4, like this. As we move like this, elasticity becomes less than 1, 0.9, 0.8, 0.6, 0.2, 0.1, and so on. Is this clear, everyone? Because this is something which is going to be very important.
Yes, sir.
Sir, can you
Yes.
please explain again that similar triangle portion?
Okay. Since I've proceeded a little bit more, just forget about it. If this is true, I'll come back. I'll come back and prove it to you. But just assume this theory. Okay. Assume this result. Given this result, can you follow this?
Yeah, I can get this one.
Okay.
I don't.
No, why I'm asking is that I want to erase this slide. So is there any question about this part? No questions? So I'll go back to this part. See, this is a problem with the e-board. Okay, price elasticity is, or I can write this as slope. Okay. So this is price, which is given by OP. And this is denominator is quantity, which is given by OQ. Okay, now OP is equal to BQ, right? And OQ is equal to PB, right? Can you follow this part, the second component?
Yes, sir.
Okay. What is the first component? Del Q. Del Q is, let us say the original price was this, and we have come down over here. So, no, this is wrong. What is del Q? Del Q is PB, right? And del P is AP. So I'm just writing it down. Clear?
Yes, sir.
Okay. So look at this triangle and the larger triangle. These are similar triangles. You're simply scaling it up. Right? So the ratio of the sides will be same in this triangle and in the larger triangle, right? So BQ is this, and sorry, no, sorry, you have to look at this rectangle, right? So the if these two are similar triangles, then this the ratio of these two sides must equal to the ratio of these two sides.
Yes, sir. I was just confused. I thought you were taking the larger triangle and the smaller triangle. That's why I couldn't understand it. But now I get it.
Okay, okay, okay. So therefore, we can write this is BC, and this will be AB. Okay.
Yes, sir.
Any questions?
No, sir. Thank you.
Okay. Now, let us just focus on the relation between quantity and price. Okay. We can think of three concepts. One is total revenue, which is given by price into quantity. So this, if you buy something by Q amounts at a price P, then this is the amount that you are going to spend, your expenditure. And vice versa, this is the amount that is going to the producer. The second concept is, sorry, this is total. The second concept is average revenue. Okay. What is average revenue? It is simply TR by quantity, which is equal to price. Now, if you take the inverse function, remember we had discussed inverse function, then this is simply, right?
So can you explain this on average revenue is TR by Q? So what is this symbol? C types?
Oh, this one, this is
Okay,
equal
sir.
to,
Thank you so much.
it's just a scratching. Is equal to. Actually, the problem with the thing is that I have to write blind. I can't see what I'm writing.
Okay, sir.
Yeah. Let me see average revenue. Okay. Now, all of you know what derivative is. So, although I've not introduced derivatives, I'm just anticipating. Derivative is the change in total revenue due to a change in quantity. Well, obviously, it's a very small change. You know the definition. Del Q has to be tends to 0. Okay. So this is called marginal revenue. Now, I want to discuss two things. First of all, you can see that average revenue is simply the demand function. We can write the demand function in either of these two. Average revenue is demand function when we write it in this manner. Okay. So that means this is the, sorry, this is again equal to. Okay. Now suppose we have a linear function. So this will be the slope. This will be the functional form a minus bq when both a and b are positive, right? What is total revenue from here?
P into Q.
It is pq. So it is aq minus 2bq square. What is marginal revenue? Actually, this should be del. Sorry, dy, not del. Okay. You know how to find out derivatives, right? So what's the
Sir,
derivative?
A minus 2BQ.
A minus 2bq. Now tell me, what is the slope of the AR function? This one.
So won't it be 4BQ?
4bq.
A minus
Yes,
4BQ.
4B.
Yes, sir. 4B
No,
cube.
no. I'm talking about this.
Sir, why is the total revenue 2BQ squared? Why?
Exactly.
Sorry, it's my mistake. Yeah, it's simply, I was just thinking ahead. Oh, yeah, yeah. So AQ, total revenue is AQ minus BQ squared. And if we differentiate, it comes to 2A minus 2BQ. Okay. Now, this is the average revenue function, right? What is the slope of this?
Sir, minus B.
Just Q.
B. Minus B.
Minus B. You just have to take the divide dp by dq. A is constant, so it's minus b. Now, what is the slope of MR? This one.
Minus 2B.
Minus. Okay. Now we have drawn over here, right? Can you draw a marginal revenue? What will it look like? Will it be a? Will it also be linear, or will it be quadratic?
Sir, linear. Sir, with double the intercept.
Okay, it's linear.
Yes, sir.
Now you, so it will start at this point, but if you look at this is roughly half. Yeah. So this is the marginal revenue. Oops. I assume that it's a straight line. Okay. So basically what I'm doing is I'm drawing a point like this. I think it's better draw it again. Right. Okay. Now, what is price over here? It is P equal to 0. So that means A minus PQ. What is Q over here? A by B. So this is A by B. What is this point? When the marginal revenue touches the quantity axis.
Sir, can you repeat the question?
What is the coordinates of this point? P is 0, but what is Q at this point?
0. Oh, no, sorry.
A by B.
The A by 2B.
Sorry. A by 2B. See, this has to be set equal to 0. So it will be A by 2B. So that means this is half, right? Now, this is the midpoint. So can you tell me what is the elasticity at this point? At A
1.
by 2B.
Unitary elastic.
1.
Obviously,
Yeah.
obviously, because I've told you that elasticity is equal to lower by upper. What is the elasticity over here in this range?
Relatively elastic.
So
Greater than 1. And over here, the
less than.
elasticity is equal to 1. Okay, so we will require these relations later on. In your second semester, you don't have micro, but in your third and fourth semester, you will require this diagram. So keep it very safely in your memories.
So can you take out the previous slide once?
Now, how? How can I do it?
So in the paint only. I just know you've deleted it. Okay.
Yeah. What do you want? I'll have to redraw it.
Actually, I was doing the graph, drawing the graph. I think that is okay. I will see it in the recording. That is fine.
Okay, I'll just draw it again. So this is what will this be?
A by 2b.
Midpoint elasticity is equal to 0.
1.
Sorry, 1. Elasticity is less than 1.
Thank you, sir.
See, note one thing, that when price elasticity is less than 1, unitary elastic, marginal revenue is negative. What does this mean? That if you are buying more, the total revenue, price into quantity, that is going to decrease. Think of it from the seller's viewpoint, right? Why do you sell? Obviously, you want to get some revenue, which is given by price into quantity. Will you go into this range? Will you sell in this range?
No.
No, sir.
Why?
Because the marginal
Because my
revenue is negative there.
total revenue is decreasing.
Yeah. So over here we can see then MR is negative. So if you sell more, what is going to happen is your total revenue is going to come down, go down. That is why you will not sell at this point. In fact, if you want to add the total revenue, it is going to be like this. So this is the maximum point of total revenue. Okay. Shall I delete it?
Yes, sir.
Okay. Okay. Now I want to just go back a little bit and ask you some questions. Um, let me see. So you've got a class of 120 students. Okay. If price is 0, then each student buys 2 burgers. So what is total demand?
240.
240.
240. Now suppose price is increased to 4. In that case, demand, no one will buy any burgers. Now assume that demand is linear. What is the demand function? In these cases, it is always best if you draw the diagram. This is P, this is Q, What does this imply?
So this is a perfectly elastic demand curve.
No, I'm not talking about elasticity. I'm saying what
Oh,
is the demand function? You have to
oh,
write out the demand function. First, draw it when price is zero, right? When is price zero? At which point is price zero?
So the
Which point?
origin,
origin.
Origin.
So,
What is
yes,
the quantity over here?
240.
40.
240.
Right. Now use this. So this is one point on the demand function, right? What is the second point? Price is 4,
So
demand is
demand
0.
is in the y-axis.
Okay. Now we don't know what it is. It can be like this, it can be like this, it can be like this, whatever, right? Uh, but so we assume that it is linear. So it's a straight line. What is the equation of this straight line?
Sir, can I answer?
Sure.
The equation will be q minus q equals to 240 minus
Just
60.
1 minute, please. Yeah.
The
Yeah.
equation will be
Ah.
q equals to 240 minus 60p
240
minus 60p.
60p.
Q equals to.
Q is equal to. Okay. How did you get this?
That is straight line intercept. The p by 4 the p by 4 plus q by 240 equals to 1.
So if Q is okay. Alternately, what you could have done was you could have found out the inverse demand function. So this is A minus BQ, right? A is 4, and you can simply take this demand function A minus BQ and plug in values of price and quantity. So you'll get two equations. Price is 0, A minus, this is 240, price is 0, A minus B 0. Right? So you get two equations and you can solve them to get A and B. And you will get this equation. Now tell me, if price is 3.90, what is demand? You don't have to find it, just tell me how you will do it.
Sir, can you repeat the question?
Okay, what I'm asking is, if price equal to 390, what is demand? Or let's make it easy. Suppose price is 2.
So it will be 120.
120.
It's
You simply
120.
have to put in the value of price over here. In this case, it is 2. If it was 3.9, it would have been simply 240 minus 60 into 3.9. And then you should have solved it.
Sir, can you please explain how did it come to Q equals to 240 minus 60, please?
See, you have your equation is, let us say, this is a linear demand function, right? right?
Yes, sir.
Now look at this part, p equal to 0. Put in 0 over here, a minus b. What is quantity over here?
When sir, 240. Yes, sir.
Right? Okay. Then when price is 4, a minus b, what is quantity over here?
0.
0.
Hmm.
Okay. So it is 4
Yes, sir.
equal to a,
Hmm.
right? Now plug this in over here. You get 4 minus 240b equal to 0. So b is equal to 60. So
Hmm.
now you can write this.
Yes, sir. Sir, can we not do it in the form of y equals to mx plus c by thinking like that?
This is the advantage of us having a also have this formula, I think. Uh, sorry, this will be x. So just use any of these formulas. Parameter two equations and solve for a and b. After that,
Okay,
if I
sir.
give you a value of p, you can simply substitute p and you can find out what is quantity. If I give you clear?
So, from that
Yes, sir.
equation 4 minus 240 b equals to 0, how can you get b equals to 60? Because if we take 240b on the other side, means then it's become plus, then 4 by 240. B is coming is 4 by 240, not 240 by 4.
So B will be 1 by 60.
Yes, yes, that's what I'm saying.
Exactly, sir. That's why the confusion.
Let's leave the meeting.
I think he had some connection issues. Even his voice was cracking.
I wasn't able to hear him the last few minutes.
Can someone tell the last equation that we got after solving the second demand question?
Which equation are you talking about?
If P is equal to 2.
Sir just used that equation which we got, means q equals to 240 minus 60p. He was taking that and he
I
got.
think we are getting 240 minus 120p equal to Q. That is the function, I believe, if everyone has got.
Yeah, means if b is equals to 1 by 60, then
Exactly. B is coming 1 by 60. You solve it in any way, it's coming 1 by 60. Or rather minus 1 by 60.
Sorry, I got disconnected. So at what point did I get cut off?
So we got B. We were confused as B is coming as 1 by 60 after solving the equation, and then it got disconnected.
Okay. Yeah, so B equal to 60.
So B is coming as 1 by 60. If you solve it, then it's coming 1 by 60, not B equals to 60.
Yes, sir. Like even if we solve it in the y equals to mx plus c form, the slope is coming minus
Yeah,
1 by
look
60.
look over here. See, P equal to A minus BQ. Okay.
So we can't
So,
see the presentation.
We
oh,
can.
sorry. I got disconnected, forgot. Let's give it.
No.
No,
No,
sir.
sir.
No, wait. No, wait. My present now is off. Yeah, now. Yeah, now?
So are you sharing your screen?
Yeah, I'm sharing it.
So it's showing
I'm not
blank,
seeing it. No,
nothing else.
Yeah, just
No,
one
sir.
second.
Not with.
Wait. Hmm. Now it's coming. Yeah, now?
Yes, sir, we can see you.
Yes, sir.
Yes, sir.
Yeah, so what I said was P equal to A minus BQ, right? So we get two equations, 0 equal to A minus B, 240, and the second equation, 4 equal to A minus B into 0. So this gives me 4 into A, right? I'm plugging this value of A over here. So 4 minus 240B, which gives me, as you have said, B is equal to 1 by 60.
Yes, sir.
Wait a minute. Okay. So I'm putting this into equation 4 minus 1 by 60Q. And if I put in any value of P, I can get the corresponding Q. Similarly for Q, I can get a value of P. Okay. Now, instead of writing in this way, I could have also have written Q equal to uh, C minus dP. Right. In that case, you will have you will get this equation 240 minus 60p.
Yes, sir. Yes, sir.
Just check
Got
for
it.
yourself. Yeah. So it depends on how you
So what's
write.
C here?
C is the intercept and D is the
Okay, okay, sir.
slope. The difference is, see, here price is a function of quantity. Here this is the inverse function. Quantity is a function of price. Okay. So D, for instance, will be the inverse of this, 1 by 60. Bring Q to the left hand side, you're going to get this equation. Now I'll give you guys, suppose you have this type of revenue. For convenience, let us assume is it convex or concave? Okay.
Sir, I cannot see anything. It's paused in the screen.
Same here, sir.
Same here.
Is sir in the meeting? Because sir's voice is cracking like that of ma'am's last, like
Yeah,
it happened
it's
last
getting
day.
disconnected. And you've also lost the presentation. Yeah. Okay. Now suppose you are a consumer, okay, and you are buying two commodities, X and Y. You can buy either zero or a positive amount of either of X and Y. Okay. Obviously, you cannot buy a negative amount. So we can write this as okay. So both X and Y can be zero or greater than zero. Draw C. Depict C in terms of in a Cartesian space, two dimension. There are two commodities, so obviously it's two dimension. So what is C?
At the region of the first quadrant.
Just give me a
The region of the first quadrant, yeah.
minute. Okay. Will it? So it's basically these parts. Will it include this also? This line also?
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
Greater than equal to.
Okay. So is it a closed set or is it an open set?
It's a closed
Closed
set.
Closed
set.
set.
It's a closed set.
Open on the other side.
Yeah. So you would say it's a
Half open.
semi-open. It is closed at the lower boundaries. So X is, in fact, there's no bounds. Yeah, just give me one moment, please. Hello. Yeah, sorry for the interruption. Okay, so it includes this part, but the upper region, upper boundaries, there are no upper boundaries, but it is closed from below. So it is, you can say mm, it's closed from below, unbounded at the upper regions. Okay. The next thing is that the consumer has a budget. He faces prices of PX and PY for the two commodities. What is his expenditure? Can you hear me?
Sir, X
Yes,
into
sir.
Yeah.
Y.
Okay.
Yes, sir.
Yes, sir.
Yeah.
PX plus PY.
Sorry.
Sir, X into PX plus Y into PY.
X into PX
Plus Y into PY.
into PY. Okay. So this is the expenditure. Now, can expenditure be any amount? I mean, people normally have a fixed amount.
Limit.
This is my budget. I can't spend more than this amount. So let this amount be given by M. What is the relation between these? This part and M.
So
Greater
less
than M.
than equal to.
Less than or equal to.
Less than or equal to M. Okay. How do we draw this?
Sir, it's a straight line curve.
It can't be a straight line curve. It's either a straight line or it's a curve.
Curve, yes.
It's a straight line.
It's a straight line, right? On which quadrant?
The
First
first
quadrant.
part.
First quadrant.
Okay. Will it be negatively sloped, positively sloped?
Negatively slow.
Negative.
Negatively
Negatively
sloped.
sloped.
Negatively sloped.
Yeah. So it will be like this. So suppose I give you the values of Px, Py, and M. Can you find out the exact line? I mean, this is something that I've just drawn. It could have been here. It could have been here, like this.
Yes, we can.
Yeah.
Yes, sir.
Okay. So now the consumer wants to purchase this commodity. Okay. X and Y, which are non-negative. So we are talking about this space. But he also wants to satisfy this budget constraint, which is called B. What is this B?
This line.
B is this line, but does B comprise only this line?
No, sir, the triangle.
Also the triangle, the points in
The
the triangle.
entire triangle. See, note now that it is closed. It can be these points, it can be these points, also these points. And of course, you can have the interior points. What is the nature of this set? Convex or concave?
So it is a convex set.
Convex set.
Convex set.
In fact, it is strictly convex, right? Now, if you superimpose both this part and this part, will the consumer buy at any combination? Can it, for instance, buy a
Sir, you're
So
not
can't hear
audible.
you.
So your voice is breaking.
combination like this?
So your voice is breaking.
Question I'm asking is, okay, let us superimpose the budget set B and the choice set C, right? Then I'm asking that will the consumer be willing to be able to buy any point, a point like this, a point like this, a point like this?
So
So
outside in
only
Sir,
a
the
only
point
in
within the triangle will be attained,
the
not
point
the
within the
has
point
to
triangle
be
and
outside
on
only
the
the
on
boundary
the
triangle.
you should
line.
buy, but
The
not
points
outside.
has to be on the line.
On the line within the triangle. Any
Yeah. So if I had
Yes,
considered
yes,
just C, it could have been any point, right?
Yes.
But now that I'm introducing the budget set, instead of an unbounded space, I now have a boundary. Okay. But which point on the boundary? In that case, I have to introduce some other concepts. In fact, I won't be discussing this concept in my class. Typically, these problems are called constraint optimization, and we use a method called Lagrangian multiplier method.
So
So that
it's
is part of your
constrained. Constrained.
constraint. It's constraint. I will be going only up till the unconstrained optimization. In the second semester, MD will discuss how to find out constraint optimization using the Lagrangian multiplier. Although in microeconomics, you will know how to uh, solve this graphically. But mathematically, the solution method will be discussed in your second semester. So what I thought was, instead of going and covering the entire course, I will focus on only the first three modules. Most probably, I'll leave out matrices because internet will be teaching about online will be slow and difficult. Uh, let's focus on something which we can cover realistically. Okay, so I'll discuss some concepts before ending today's class. So remember that we had discussed concepts of, can you see this PPT, by the way?
Yes, sir.
Yes,
Yes,
sir.
sir.
Remember that we had discussed the concept of convexity. What is convexity? That we take two points and a point in between. If we take any two points and connect them, they will lie within the set. For instance, if you take any 2 points over here, the line connecting them, these 2 points, will lie within the set. Like here, here it depends. It depends on what 2 points we are taking. So we had defined convex sets in this way. Now, when we are using using functions, we can also define convexity. A function f is convex. See, this is the mathematical definition. Uh, just go through it. So this is an inequality V, but if it is strictly convex, it becomes a strict inequality. A line. If this okay, if this function, sorry, if this chord is above the function, we call it convex. Concavity, the chord must lie below the function.
So I cannot see the presentation.
Ah, it's gone. I heard a sound, but I didn't understand what it was meaning. Yeah. Now is it clear? Can you see this?
Yes.
Yes, sir.
See, what we're doing is we're taking a point x1, we are taking another point x1, x2, and we are connecting a line. Okay. So if this line lies above
So your voice is
the
breaking.
curve, it is said to be convex. Hmm. Okay, I think I'll give up. It's better to cover it later when the connection is better. Okay, I just have 5, 6 points. I'll cover it in the next class. It's time also. Okay, so next Monday, uh, my classes on Monday and Wednesday, right? Monday again, I have to go to the hospital. So, but next week I have to go to the hospital on Monday and Thursday. So Thursday I don't have a class. I think MD has a class, right? Let me see. So MD will tell you when she's going to take her classes. MD will have to change her Thursday class. Tuesday, I think she will be able to take her class. So Monday, if I shift the class back to 5 o'clock, is it okay with you? Hopefully, this is the last week.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. After that, I'll be more or less free. So next week, I'll take at 5 o'clock. In between, if you can look at these problems, page 50 in Hoy's book, page 56 that you've solved. Mm, Page 57, question number 4 and question number 5. Okay, try to solve these two questions.
Sir,
Um,
can you again
Page
repeat the
number?
question?
Yes, yes.
yeah, did you get the message?
Yes, sir.
Yes, sir.
Yes, sir.
Sir left the
Which
meeting.
book? Which book are we supposed to do this from?
I guess Hoy's book.
Hoy. Hoy's book, Hoy's book.
Oh,
Yeah, sorry. I've posted the questions. So just check over there. Uh, and please download Hoy's book from my Google Class. Okay. So I'll meet you next Monday. And if you have any problems midway, please contact me.
Sir, I just wanted to ask that the demand function and all those portions you taught us today, from which book are we supposed to read it?
You mean the derivations?
Means
Or
the whole portion, like you taught us the demand and elasticity part and also TR and MR portion.
mm, okay, I'll let you know.
Okay, sir. Thank you.
But I'll give you a very basic book in which you can. One book is Salvatore, if you can get it. Let me see if I can find it on LibGen.
Okay, sir.
If I can get it, I'll post a reference. Okay. Any other questions? Okay. In that case, I'm closing the class. Uh, Goodbye. We'll meet again on Monday.
Thank you, sir.
Thank you, sir.
thank you, sir.
Thank you, sir.
Thank
And
you, sir.